Hi, in this video we're going to find the height of a pyramid using Pythagoras theorem. Now remember the key of using Pythagoras theorem in 3D shapes. We just need to identify a 2D triangle somewhere and then we can use Pythagoras theorem. So can we somehow find a 2D triangle here that's going to be useful? Well, what information do we know? We know that this slant height is 21. The slant height of a pyramid is just like the length of the edge that's kind of going at a slant, at an angle. And we also know there's a square base, and this is a square at the bottom of 18 by 18. So we can copy this 18 here as well, for example, because it's a square. Now, what can we use as our triangle? Well, we're trying to find this vertical height. What we could do is if we were to add a length like this, going diagonally like that, then can you see that this is a right angle triangle here? That this triangle here is a right angle triangle. Now, we know one of the lengths, the hypotenuse, the longest length of this right angle triangle is 21, and the h is what we're trying to work out, but we don't know that blue length. But we could work out the blue length because we could consider this diagonal across the base, the square base of the pyramid. So let's draw out the square base. So we've got the square base of the pyramid, and it's 18 by 18 base, a square like that. And we're trying to find this blue length, which you can see is from like the corner of the square to the center of the square. So it's basically this length here we're trying to find, right? But what we could do is if we found the total length of the way across, let's do it in a different color or just dotted. If we found the total diagonal across that square, we could halve this length to just find that solid blue length there, right? So how do we do that? Well, we can use Pythagoras theorem on this base. Now remember how Pythagoras theorem works. If I just highlight that in purple. If you label the two shorter sides as A and B, either way around, and the hypotenuse, which is the longest length of this triangle, as C, then Pythagoras theorem is A squared plus B squared is equal to C squared. So the A here is 18, substitute it in. The B here is another 18, and the C here is, we'll just keep it as C. So 18 squared plus 18 squared, let's just do that, is 648, is C squared. And then C is going to be the square root of that, so we do the square root of 648. My calculator gives me 18 root 2. So this total length here is 18 root 2, but we just want half of that because we just want half of this diagonal, What's half of 18 lots of root 2? Well, it's 9 lots of root 2. So we know, therefore, that this diagonal here, half the diagonal is 9 root 2. Now we've got everything we need in that yellow triangle now, because we've got two of the lengths, we can work out the third using Pythagoras theorem. So let's just draw out that triangle, the yellow one, like this. It's yellow, let's highlight it as yellow. And what are the lengths we've got? We've got the 21 as the hypotenuse at the top. And we've got the base, that bottom length is 9 root 2. And we want to find this height, which is that red length, which is h. So let's just use Pythagoras theorem again. Label the two shorter sides as A and B, either way around, and the hypotenuse as C. So we're going to use A squared plus B squared equals C squared again. Now A is h, so it's h squared. B is 9 root 2, so I'm going to do 9 root 2 all squared. Notice I've used brackets because I want all of the 9 root 2 squared. And then the C is 21, so it's 21 squared. Let's use our calculator to simplify. Actually, we could just about do it in our head, because if you want to square the 9 root 2, you square the 9. 9 squared is 81. And root 2 squared, well, the squared cancels out the root. So root 2 squared is just 2. 81 times 2 is 162. So we get 162. And 21 squared, I believe, is 441. So we can subtract the 162 from both sides. 441 minus 162 is 279. And then you just square root both sides to get rid of that squared. So square root of 279 is equal to 3 root 31, but it wants as a decimal to one decimal place. So let's convert that to a decimal. We get 16.7 centimetres. And that's the final answer. It's 16.7.